Okay, so welcome to XP Manchester. There's quite a few new faces here, so again, for future reference, and we'll be clearer about this on invites and stuff in the future. We normally start at 7 o'clock, doors open at 6:30, which is why we've had this long wait at the beginning. So tonight we're going to be having a goldfish call about microservices. So as we said earlier, if you want to speak, come up and sit down. There can only be 4 people sat down at a time, so if someone comes and sits down, someone in the middle has to go and sit at the edge, if that makes sense. So I thought a good starting point might be for everyone to discuss what they think a microservice is. Let's start us off, someone.
Well, I've not read a lot on it, but I don't think there's a strict prescribed way of building a microservice. It's more of a philosophy. You might have a messaging into action. Words aren't coming out here. You might have a direct service-to-service communication, or you might have a message box in the middle. But start at the beginning. Microservice is a service that does one thing, does it very well. It's very low scope, so it's not like a monolithic service where it just knows about everything. It supports failure, and you build a system from lots of microservices, sort of composing together. And the idea of that is you don't end up with this monolithic beast of an application. Yeah. Is that one? What's your thoughts on it?
Microservice is a way to give your operations people a really big job to do.
Oh yeah.
That's microservice architecture. So if you have a set of small services...
Well, if you've got one big problem, let's just spread it out. Spread the problem across multiple places and just make it small problems in multiple places. But it's not, I suppose it's not a big problem. My view on microservices, I suppose, is something that we always did at different levels. If somebody's, I think when you talk monolith and you talk about coding, for example, I think we all understand code here. I hope. If not, that's fine. I hope you learn a lot today. But in coding, you have that monolithic app. Let's say you build a .NET application there. All the domain knowledge of your application is in one project, and that project, I don't know, you sell beach balls and put all the knowledge, all the business logic about beach ball sale within one app. And then one day you come in and say, "Paul, this is really hard to manage. What can we do to break it up?" So you decided, well, microservices, I think, it's the idea that we always did that. We just now brought it to the service layer where we look at this monolithic application in multiple ways and how can we create bounded contexts, separate them into smaller chunks so we can manage them better. So you might say the sale part of the website, you actually move into a separate DLL where it's easy to manage. So if you can just go in and just change the sale DLL. And then comes the other idea about, well, if I want somebody else to consume the DLL, we might, well, let's put the DLL in NuGet, or I could create a service.
Well, you say that we've always done this, but as an industry, we're spectacularly bad at it generally.
We're bad at everything. It's shown by, it's a good example. One of the work that I used to work with a guy. I used to work for a place called Dr. Chambers. They do medical legal documents. And one of the contractors was building a smart client application. And we had the GPs coming in testing the app. And the GP said to me one day after talking to him, "We have a word for developers in the medical industry." I say, "Really?" "Yeah, we have a saying." I say, "Well, what is it?" "Developers are the dentists of the software industry. The work is really expensive and it's crap." So it is not everywhere it's a generalization, but we tend to hear buzzwords like, microservices, the current buzzword, and people saying, "What is microservices? Is this and that?" And we
people saying, we want to do this.
We want to do
We
it.
want to introduce this
Yeah.
complexity into our
But it's supposed to make it simpler, right?
I think that the way they came about is due to the complexity.
Yeah.
And due to the problems with, let's call it a monolithic system. Whether that's a solution with 8 different projects, so you're breaking things into different sort of chunks, like a repository pattern, you've got entities, you've got a service layer, but it's all kind of in the same mix, and there's a lot of complexity there, especially when you're trying to enhance the system and take it in a different direction. I think that's where microservices has come from. It's trying to deal with that complexity by saying, well, let's just build these discrete things that do one thing really well. My issue with it is that you might end up duplicating, like one service does one thing, I don't know, deals with an order that's come in, puts into the system. So that's got to have a view of an order. So you have like an order entity and it might have some business logic. And my worry is that...
Wouldn't you just instead go and call the order, the put and get order service? Instead, you're dealing with the order might not be... for example, where I work, we have static data about specific stock items where literally it's just read only. That's all it does. If somebody wants to read the stock item, they go to the service, they read the stock item, but the service has no logic whatsoever. It's just for you to read the stock item. It's really small. It's just for that, and it's not for anything else. So if you want to talk about the order bit, somebody has to go and build the order service. About this item, because this service doesn't care about orders, just care about this specific stock item, this product, if you like.
Sure, I mean that's a good example, good use. I was just trying to think of places where you'd have different services doing different things, but they need the same kind of entity, and you kind of duplicate. I feel there's a danger of duplicating behaviour.
When you go on.
It's not really duplication. It's the same thing as an order.
Yeah,
but this service may think about that order in a different way.
Sure, it's a different context, isn't it? So,
I mean, any other service that needs an order, and if a hypothetical scenario where we have an order object and you have an order service, if somebody wants to read an order, they don't go to the database, they go to the order service. You don't duplicate the access to data. You don't allow people to access order in different ways. If somebody wants an order, they get it from the order service, and that's it. Otherwise, how can you abstract? How can you start? How can you abstract your data if you're allowing multiple people to have different views of it?
Well, this is part of the argument for making it less complex. You're dealing with one or a small number of concepts at a time, rather than potentially reaching around to different bits of the system, grabbing that because you can, sticking that in the database because you can, grabbing this out of the database because you can.
Yeah, exactly.
And therefore, as soon as if you break that down, you can start to say, well, this service also needs the order as well as the order service. So you may as well just abandon it, or all you've done then is just create a monolith with distribution.
Yeah,
and distribution is hard.
It is. Distribution is hard. But we're trading, making a trade. You trade off about, you have this huge blob that takes a lot of people to move, but what if we break up this huge blob, create some sort of duplication, because there'll be certain situations you have to make that decision, that trade, I have to do this and have to take this hit because I can't do it otherwise.
I think that's what I'm trying to say at the beginning. Like, there's not a set prescribed way of doing it. It's all about the engineering trade-off of when it's a good way to do it this way or do it that way. Is what I was trying to say.
But this is why the whole thing about simplicity, the microservices give you simplicity, is bollocks. Because all you do is you play whack-a-mole. So basically, you make it simpler for the developers because they're dealing with one concept at a time when they're working with services, and you just make it far more difficult in terms of deployment, in terms of operation, in terms of cost. All there is also, if people say, okay, how many microservices do you have per repository? Yeah. If you have one microservice per repository, and a microservice is code that fits in code that fits in your head, so two pages full of code, then I want some shares in GitHub because and also AWS.
Yeah, go on.
I couldn't agree more.
You need to
have to stay, right? So, my question then is, which it is, how big is a microservice? How big is it?
Well,
Yeah,
that's a good
oh,
point. Well, can I answer that?
Go on.
From another
Yeah,
point
of
of
course
view.
you can.
Right.
You're here
I'm
to
actually
say
working on a microservices system now.
Yeah.
Now, my background is I've worked on eventing and CQRS systems for quite some time.
Yeah.
But this is the first one that's actually used the moniker microservices. And what we've ended up with is, everybody knows the repository pattern. Yeah. We've ended up with the microservices repository pattern. We have a microservice for every table. And that table sits on its own database. And we have...
Well, that's wrong.
well, exactly.
You don't do that. It's about building the bounded context.
Yeah, exactly. But no, this is my point. You see, I haven't actually developed this, so let's just.
That's okay.
Everybody.
I'm talking for
Everybody.
No, this guy will know this because we used to debate about microservices for a while before this. Anyway, so what they've ended up with, they've broke it down to every basic table to a microservice. And then some PMs come along and said, we need this to do this domain. Yeah, right? So they've gone, how do we connect these up? Well, we'll stick a web API on that one, we'll stick a message on that, we'll stick a bus on that. That'll do it. And we've ended up with a system that does login and registration with, can you help me here, how many services do we have?
About 8.
About 8. And they're intertwined like the worst, daftest, drunken spider's web you've ever seen.
That's why it goes what you're saying. It's just
So we all
making a
know
distributed problem.
Yeah. So we all know there's no pattern to
Yeah.
this. We all know, we're all learning.
But
But people, they see it, they try and break it down based on other patterns, and you ended up with this thing. Now, when you've only got this such a simple problem, it's become like this spaghetti junction of a monster. We have mobile tying into this, we have web guys tying into this, and they're having to do multiple calls to get a login.
Well, I think it's two problems here. I think one is that I think Simon Bryan who said that if you can't create well-structured monoliths, why the hell do we think we can create well-structured microservices-based architectures? And the other thing is that another quote I think was from Liz Keogh about the developers were attracted to complexity like moths to a flame, and if we don't find it, we create it. Now, I think this is part of the thing with microservices. It's bringing in, as you say, different technologies. Hey, great, we can write every microservice in a different technology. Why the hell do you want to do that? Who's going to recruit the people who are going to maintain this on an ongoing basis?
Is there an argument to say that what we've actually just done is taken object orientation and moved the objects into the microservices? We're taking encapsulation and we're saying, oh well, let's just call them microservices.
If only that were true. What a wonderful world that is. Because there used to be a technology that let you build arbitrarily complex systems out of little things that did one thing well, and they communicated with each other by sending messages. And each of them kept a little bit of state hidden to itself. And you could spread them around the network and they could chat to each other, and it was all fairly transparent. And there were clever ways of making them have a long life, perhaps across process boundaries, which was called
Corba? Further back.
Erlang is another good example of that sort of thing.
Small talk? Yeah.
So we had Smalltalk that did this extremely well, but on the assumption that you had one process running on one machine. We've got Erlang that does this extremely well on the assumption that you have many processes running on many machines. Who here has been paid money to write Smalltalk? Who here has been paid money to write Erlang?
I'm just going to lie.
Yeah. In dream world, that's what we do. Okay? The technology exists to do this kind of stuff right, but nobody wants to use them. What we want to do is twat about with Corba. Ah, dear. Those are the days.
Yeah.
Corba, there it goes. Soap. All that sort of nonsense. As I recall, nobody ever really knew what a service was. Like, nobody ever really knew what a component was, but everybody built service-oriented architectures, and everybody built component-based platform, system, framework.
But this is the problem. Isn't it essentially that we've had ways of partitioning systems. We've had components, we've had objects, and so on, and people generally use them pretty poorly. Yes. And I think this is so taking that to another level and distributing everything.
I agree with it. I think you've got three things. You need discipline in a team to deal with any problem. You need experience in that team.
Yeah.
To not argue over technologies, argue over the actual problem you're trying to solve. Yeah. And I think if you haven't got that, you're not gonna build a good monolith, and you're not gonna build a good distributed system. You're not gonna build a good system. Full stop.
I've heard it said a lot about microservices that in order to be able to actually build a good, well-designed, efficient system that's based on microservices, then you need a mature team that knows what they're doing and is very talented and all the rest of it. And that sounds great, but I mean, even if you had that team, given the level of turnover that there is in IT and the level of movement there is, and the theory that every time somebody leaves a team, you get a new team and you have to start again, then does that mean that what we're really saying is that microservices is actually too hard? Because it sounds like that's what everybody here is saying.
So I would suggest that microservices are too hard because everything's too hard, and what you described there is the necessary but not sufficient conditions for the success of a system construction enterprise using microservices. Well, that's true for any value of microservices. You need an experienced, capable team who are focused on the problem in hand, and if you have that, it doesn't really matter what the technology choices are. We're sort of, we're technologists, and Liz Koff is right that we're attracted to complexity because that's fun and exciting. Fingers on that, lovely.
But without necessarily doing the due diligence to get competent at it.
And the third one, which I didn't mention, is actually knowing your domain. The last thing you want to do is you've got 8 microservices, 10 microservices, and a PM comes along and says, what we've done there is absolutely bollocks. We need you to do this, that, and the other. You refactoring that. It's a nightmare. It's completely.
But this is why there's the argument about whether you should start from a monolith. Basically build the monolith and then carve it up once you know.
Because you know your domain, you know what's expected.
There used to be
I'll let me by myself.
there used to be a saying that has fallen out of use. I haven't heard it recently anyway, but I think it's very true. That every complex working system grew out of a simple working system. But again, we don't in the industry tend to maintain that evolution towards a more complex system. We just going to go full bore, maximum complexity, turn it up to 11 on day one, throw in everything we can think of, and the end result is unhappy users. When I was sitting in the back there, I looked up the earliest reference to microservices, and originally it was micro web services. And the definition that was presented was a bit of computing resource that does some work for you that's on the end of a URI. Full stop. That's all it is.
How long ago was that?
That was about 10 years ago.
Because I don't think there's anything really that new about the idea of microservices. Because I remember back in the 80s, IBM coming in and telling us about this amazing system they had for coupling together small pieces of functionality with messages and that kind of thing, which was MQ series, if you heard of that. And it's exactly the same thing, and that was 30 years ago now. So
Yes.
I don't think is that new.
Oh, none of it's new. Small talk systems were built this way in the early 70s. None of it's new. We just go around and around. One of the things that dismays me about the industry sometimes is that we travel a very long route to cover a very short distance, and then we think we've been clever, and then we do it again. And sometimes we travel a very long route to go backwards slightly, and think we've been even cleverer. And
I think we're always reinventing things. That's definitely true. Every time you see something, anything that's brilliant, you look at it, you think, well, it's a bit like something I used 5-10 years ago. That's absolutely right. Yeah.
So going back to moving from monolith to microservices, the concept of how small is a microservice versus how large is a macro. A platform we've been building recently is we've been deploying the idea of the bounded context with event-driven architecture between employing CQRS within the bounded context, so we've got query and command separate. I guess I'm not 100% sure whether or not they're becoming, the bounded context themselves are becoming monoliths, and actually within them we should be trying to move more towards microservices. But I see there might be actually a number of prerequisites to even achieve microservices. You have to be able to cheapen the cost of deploying a service or creating a service in the first instance, which I don't think we're particularly great at, although we have been cheapening it as we go along. And but at least starting with a semi-monolith, I'd imagine, is at least ensured, at least getting the data in the right places. Microservices, I think we're seeing actually are popping up in between them with the event-driven architecture. So a small app has a single job to do between our bounded contexts. I don't really know what point I'm making with this, but it's more about how small really should we be going with this? And I'm not 100% sure with microservices how small is smaller, or is it small enough, or are we at the right level? It's hard to judge.
What figure of merit that has nothing to do with microservices would tell you whether or not you've got that right?
That's a good point.
It's quite an easy one, I think. It just doesn't work.
It does work. Are we able to change quick enough? I'm not 100% sure. We've got, even with the boundary context that we've got and the services we've got, there's an amount of data flow between them. The distributedness of the architecture is sometimes troublesome for some of the developers to grasp, and to ensure that when they do something over here, as it flows through, it causes an issue over here, which is obviously a negative.
So I always feel like there's too much of a worry about how small a microservice can be. So a microservice does a job, and that's it at the end of the day. So it's an object which does something. It can be bigger than you think. It doesn't have to be like this tiny little bit. It just needs to operate on a small scale. So if a microservice seems a bit bloated, it may be the right function. You just can't worry about it too much if that's where it's done. It has to do a single function. It doesn't need to spread out across loads because it seems big. It can be fairly large, just a stack. It's not like a huge amount of different things. It's one thing doing one function. That's it at the end of the day.
I think it's an area of concern, isn't it, rather than... I think if you've just got it doing literally one... Someone's not to leave. Sorry. Okay, fair enough. If you've got it... I've lost my train of thought. I think where we've got our application organised, which is described as microservices, but it's not really. It's like an area which is what one piece of functionality, like a customer, and that exposes several actual services which are all to do with the customer, and it's got its own set of tables inside the database. We don't have a database obviously, we've got a shared database, but the customer service just handles the customer tables and then hands out services for everything else. So it's also somewhere in between monolith and microservice. I think that seems to work quite well for us.
Something I was thinking about as we were talking, as you were all talking about different areas, I've seen microservices coming about because things have gone from small to big to monolithic, and then teams growing because those monolithic things are really big, but also there's loads of things that the business people want to do, which is great. We want to deliver stuff for business people, but those monolithic things become a bit too big to manage as one big monolithic thing. Oh, I've committed that. Oh, that's broken this, or and all the. So then we start thinking, all right, we'll slice things up, and we start slicing things up almost because
to break the dependencies.
Because the teams have become too big. Because people have started tripping over each other. Because if you only had one guy maintaining a monolithic thing, he'd maintain that one monolithic thing, and there would be no problems. Apart from, obviously, there's only one guy, and he's got lots to do. So we give him a friend to help him, and another friend, and then they fall out, and then another friend. But
that's why you get these dependencies with releasing something. You can't, because it's all part of one thing. Oh, that's a shame. One go, and that's another attraction to the microservice.
I'm wondering if it's a people thing rather than a software or even an architecture or anything like that. Is it actually?
But it's an architecture, but it's the driver is it to do with releasing different parts of these subsystems, being more flexible in that way.
So if you had one monolithic system that could be released quickly and reliably, we wouldn't really have that problem.
I'm going to call bollocks again, I'm afraid, in the sense that if we got if you've got a monolithic system and people are tripping over each other when they're trying to implement functionality, why is it going to be any different if you split those into microservices? If you take that design and then split it out, there's still going to be a bunch of things that are going to need doing across a whole bunch of different components.
Yeah,
in order to get
because by doing it,
functionality.
you've got 2 build pipelines instead of 1. That's what people think it's better.
Well, because then you've got to focus on the contract, so you've got to say, okay, well, you're then going to negotiate on the contract for that service. It's going to have to change if there's a change that's going to ripple through the system in order to make that functionality. And this is where I think that there's a bit of a danger.
There's definitely a danger there. I mean, you can do certain things where it's contract agnostic in the sense that you use messaging and you know, one specific change over here doesn't really affect the other side of it.
No, but it's the function. If the functionality is going to change, the chances are that the message will change. Otherwise, you can't make the same call.
Yeah, you just increase complexity. Yeah.
So for me, that's the implementation details. For when I look at the software requirements or what client want, what are the pain points in the monolithic system which are hurting us, and how this architectural pattern we try to use to gain advantage. And I think the most fundamental thing we all developers forget is the cost, return on investment. Someone is paying for that.
Yeah.
And if we are jumping on a bandwagon and saying, oh yeah, we're gonna have a microservices and we're gonna implement that, what are the consequences? Are we geared up to maintain the system? Or is there going to be 150 services flying around everywhere and everyone running like a monkey and find out what's actually happened? Yeah. So I think some basic fundamental things need to be done before we jump onto this. Yes, these architectural patterns are good to solve a problem, but they are for a specific problem.
Yeah,
for example, the bounded context has been mentioned loads of time. So we know that domain-driven language or domain-driven design you can only use in a very complex systems. Now, if I'm writing a simple CRUD system and I say I want to write a domain-driven design in it, I can't justify that because the cost is high. The analysis of the bounded context and the domain is very, very expensive. Then the implementation, then the deployments, and all these things I think we often forget.
Well,
and we get too busy in implementation.
Walk into
yeah.
It's too late.
Yeah.
But this is why the whole thing about the drivers. If you look at where this came from, the organisations like Netflix, for example, where they're working on industrial scale, and all these things that people talk about, using your servers like herd animals and all this sort of stuff, is great if you're at their scale. You've got to do those sort of things to survive. That's why they ended up doing them. Whereas there's no point in, as you say, in small applications, trying to pick up on all these things that are needed for industrial strength stuff. If you like sort of building a model plane to the same degree as you would do for a commercial airliner, it's like, why the hell would you do that? But unfortunately, because it's software, it appears we can do that because nobody charges.
So, sorry, go on.
The main thing, something that we've all learned through our experience of working in different places and so on, and something that they always carried with me is simplicity. So, it's like you said, very very expensive. It's not just expensive, but it's DDD, business objects, microservices, you name it. Put a name architectural partner or whatever. It's built to solve a specific problem. You look industry leads like Martin Fowler or King Beck talking about TDD, talking about microservices and everything else. They are working in huge projects and they are watching very highly skilled people working in really complex problems where these things actually have a home, that actually they're solving a problem that it's needed for. And you may say, like, microservices are great. 18 months later, Martin Fowler comes in and say, actually, they're great, but your problem, you need to be this tall, and your problem needs to be this big for it. And but we all attracted to shiny things like the mothballs, we listen to all these wonderful things and we want to try it out. We want to play with it. So we will write our golf course there for my cousin. He owns a golf course, and I'm going to do the booking system with.
But this is just unless it's an explicit experiment by your organisation to explore it. It's dereliction of duty from the software developers.
For example, I tend not to agree. To you anyway, but what I'm trying to say. Well, I don't want to go into my rant, but
go on.
Okay. I wrote a blog post a long time ago about if Picasso was a software developer. I think Picasso would have been great at software developer nowadays. He would be earning a lot of money. He would be making so much money, maintenance work he would have to do. And I think all of us have a little Picasso in ourselves. We're not only just Picasso, we are attracted to the shiny things, and it's not our fault. Okay, sometimes it is. We don't know better. We have industry leads telling you all these wonderful things you can be doing, and people in your business often let you do. They don't understand the problem that you're working on. It's like they don't understand IT, or they don't understand the software delivery, and you are.
But this is the thing, they're relying on us. They're relying on us as software professionals to actually make good decisions for their business context, which includes the amount of money they can afford, the number of people they have, the technology, the skills those people have, the capabilities of those people. All those things should form part of the context of if somebody says to us, right, now I want to design give me a system that does X, then we've got to take all those things into account rather than just picking out, as you say, the shiny thing.
But that's where you pay good money for the good developers that actually deliver it, and projects where it's successful and they're early or they're etc.
It's now when the architects keep changing their mind.
I agree completely. That's a jib at me. But they do.
But take what's happened where we work. 1 week we're all writing everything in .NET. A couple of weeks later, someone's read a blog post that Node's dead shiny. We should use Node. So everybody jumped at the bandwagon. Let's use Node. A couple of weeks later, no, Java's now a cool thing. Again.
Java's still a cool thing. It was ours a cool thing.
Exactly. But no, now it's Java. Oh, now it's Kafka. Now it's something else. The guys that keep saying that haven't written a single line of code of it.
Wow.
This isn't just the target. I think some people keep saying, "Oh yeah, change this," and the names you've quoted, the Martin Fowler's and whatever.
Yeah.
Sometimes they don't get their hands fully dirty. They just do a lot of.
No, but to be fair to Martin Fowler, if you read his blog posts around
microservices,
he does say we're not going to know how this works until until a few years when we see how they've bedded in, see how they operate, see how they
cares about that.
And also the fact about different the initial the other thing he said, and I just found this sort of thing he said was about the fact that it's ordinary developers, average developers. So at the moment, a lot of the microservice systems have been built by the initial microservices have been built by the more capable people, because they're the ones who are in the middle of Netflix trying to make sure the whole thing doesn't fall over. Once you've actually had some systems built by average developers in a microservice style, but then you've got to compare them against the equivalent of a monolith built by average developers in microservice style. Only then could you really say, this is better in that given context. But the whole thing about trying to pick this up and using, people throwing this stuff out, it's like, well, you should use this because Martin Fowler says you should use it. He said this is small print. People
they don't want to
read the small print in the article.
They want to try it.
I think some of the fault lies with the developers as well, and I admit we are really damn good at constructing very complex problems for ourselves. I'll give you an example. We don't push back some of the requirements when come in. We're just too busy finding the solution rather than start taking a step back and saying, hang on a second, what's the probability? So I'll give you an example. We're working on a Vodafone system, very complex, feeds coming in, changes happening on the mainframe, whatever business platforms they have, and the changes happening in R. So someone came in, hang on a second, if customer changes address on a main billing platform and changes address on our system, so which address we're going to use? And start back, hang on a second, what's the probability of this? maybe 1 in 1,000, right? So do you spend 3 weeks working on this to solve this problem while we can do a lot of other things? So sometimes we have to push back and say, hang on a second, think about it. That might not be feature you know required.
But quite often the answer is yes, because that's an interesting, tricky problem, as opposed to just doing more crud shoveling backwards and forwards to the database.
No. That's
you
a
need
different
some
thing.
microservices, man, with you application databases. That's what you need.
No, you didn't work for Vodafone, so you might not know anything about complex problem they have.
Event bus.
We had an event bus that was based on a CQRS system, and we did not get access to them for security reasons and data access problems, laws, European laws and whatever. Anyway, that's a different thing. So
before we go too far away from talking about microservices, perhaps now would be a good time to talk about the deployment and configuration problems that you might run into in the microservice architecture.
Well, the interesting thing for me is testing. If you have a bunch of microservices and you say you have a significant number of services, say more than 5 or 6, that you're going to put together, you then got the question of how you're going to test it. So are you going to test it in a traditional test type environment, an integration test environment, this sort of thing before you go into production? Or are you going to flip yourself, invert yourself and say, basically we'll monitor what goes into production, we'll deploy the services individually, and if alarm bells start going off and klaxons and so on, then we wind that service back out and try again when we work out what the hell went wrong.
well, there's a different, depending on how the architectural pattern is implemented. Some clever tricks can use. For example, let's say if 2 services are not talking directly, they're talking through a RabbitMQ or any messaging platform. You can have a clever monitoring system to say how many messages gone on and how many came out. That's another something, and you can have actual self-healing systems. If rather than blowing up and say, I'm down, what's the compensation for it?
Which is fine, but then it means that everybody who's building those microservices needs to be very aware of how to build a resilient service that can deal with the fact that some or all of the things he needs to do to work maybe down, and what it does is
The crux of it comes down to everybody doing their job properly. And if you do your job right, I know I'm really generalizing here. I think if you're doing a lot of services, our problem where we work is not very big. It really isn't. We got like a handful of services in there, a big monolith piece of crap over here that we're trying to make it go away. But the one thing that we still don't have is, I think, you can't just kind of separate in the middle. You can't just do the middle and forget to do the things that underneath it. Like if something that we do is rates, the cost, the rates for specific products that we have. Previously, they were sitting in the monolith database, and we can create as many freaking layers here that deals with rates and they're all microservices and everything else. But when it comes to testing, somebody can make a change here that mess around the data here, and then suddenly breaks something over there, and you go and put it live, and you go, oh shit, it's not working. Why not? Because of that. And there was some data that we didn't have on our test database, and oh shit, okay. Yeah. So if you're gonna do,
so the thing
you have to go application. You have to kind of vertical slice almost. Otherwise, you get your testing as well in a sense that you have to. I don't know.
So I don't. On the testing bit, it's almost who owns it. Who owns like that contract? So if you make a service of what comes in and out of a service. So say it's a RESTful microservice.
Sure. Yeah.
There's a call that you make and you get some data out of it. Mm-hmm. So the first client for that is almost who defines that interface.
Yeah.
But then there's a second client for it who wants something different. But then that might break that, but then that doesn't match.
That's where you need.
So then the guy in the middle, the actual service, do they own it? Do they own it? That's where we've had a lot of problems.
So, for example, the team that I was working before, prior for me going to the dark side and forgetting to code, we had the problem. You know, even the last week you came out, you know, the team that you're working on asked, we need a new feature in there, and I said, absolutely should be there, and it was being done there. But I had so many times people coming in and saying, we want to do some crazy thing that semantically has nothing to do with your service, but we believe this should come from it because we consume your service and it's the best place for it. And you go, no, it's not. And then you have they have a very year-long fucking discussion and argument, say, no, it's not going to go there. I'm never going to do this. You have to go and do someone else. It's your problem, not mine. You just this is about potatoes, not potatoes with alarm clocks. Okay.
Something I want to talk about the cost of microservices. So we've spoke a lot about how developers like to go to the bright and shiny, and Naz has talked about cost, and there is a massive cost overhead when you take the monolith X to a monolith and you say, right, we're going to cut this little microservice out, and some of the costs, at least around infrastructure, are, well, for every microservice you use a Microsoft word, for every microservice you stand up, don't ever say stand up. For every microservice you stand up, don't ever use that. You're going to have to put a watchdog next to it to make sure it's there. You need to address potential issues with concurrency because now there might be multiple versions.
They come down for
you also need to account for the fact that now you've moved into the network layer, and actually internet network issues could prohibit the system from functioning at its optimum thing. There's a lot of costs incurred and then monitoring in
but if you can't afford it, why would you do it?
But no, it goes back to the problem you're trying to solve. So when you're trying to solve a problem, what are the pain points? And when you look at the CAP theorem, and you say consistency, partitionability, and availability, you only can pick two of them, right? So if you pick partitionability and availability, so you're going to suffer on consistency. So your system is going to be eventually consistent, right? So when you deploy the eventually consistent system, the developers who are writing the system have to understand how the eventual consistency works.
Yeah, of course.
Right? And the person whose the infrastructure is available for deployment, that have to be geared up for eventually consistency. If they all microservices are bundled up because the client can't afford 10 different servers and all end up in one server, what's the problem you're trying to solve?
I mean, it comes down to, I'm going back to the point about the kind of deployment and testing and everything on microservices. It really is. It's like, don't jump the bandwagon if you can't.
There must be good solid reasons for cost benefit, and the support should be available there to provide the required infrastructure. And James, one of the things mentioned is about testing. Now, if there are different systems independently working and they need independent testing, but making sure when they come together, when they come together and they work, making sure at what level that they are and what's the cost for that as well.
It's depending on what you're building and how complex the problem is.
You were saying about the cost of like don't do it if you can't afford it, but I think there's a number of prerequisites that you need to do to achieve microservices to be able to cheapen the cost enough. One of the arguments that you just said was, someone trying to put a clock in a potato, it shouldn't be there, so why are you putting it there? And one of the arguments as to why they would be wanting to put it there is because it's too costly to put it somewhere else. It's too costly to stand up a new service, put the data in there. And I see that time and time again when
often the time when somebody wants to put a clock on my potato is that they just, for example, the specifics, this is not the potatoes in here, forgetting the abstract, the specific problem is something that specific part of the business went shed loads of money to get some third-party company to come out with a huge index of ID to ID, and they said, we need to, every time you return, we don't want 404s anymore from your RESTful interface. That doesn't work with us. In fact, when I ask for a potato, I want an apple. Because if the potato doesn't exist, I would like the apple.
and it's just like, but you know, this service says it's not. It really isn't for what they wanted to do. This specific part of the team, they want to do personalization on a website. It doesn't live within the layer where this application is. It sits with much higher in
So
the
that's
stack.
the understanding of the differentiation.
What they're
between
trying to solve,
microservices,
yeah. Well, telling you, yeah, they can't.
So I know it. We've got one type of service and we've got another type of service, but we have a view where you can see all the services.
You might not
You
even
wanna
be a
go to one
service. It
side
might be
or-
part of a different app.
By service, I mean
Yeah, I
an actual
understand, yeah.
physical service. But yeah, you got your mid-level services, but generally you want to get which one do you want to get?
Exactly.
And we don't have that in a microservice. We have that in one service. Both services live in the same.
Talking about deployment again and integration, imagine your monolith is a sphere, and think about that you want to calculate the volume and the surface area of the sphere. If you decide that you're going to split that sphere into several smaller spheres, the volume will stay the same, but the surface area is massively increased.
Yeah.
And the integration and the deployment comes with the interaction between those surface areas. And that's what worries me, is that by creating several smaller objects, you've increased the surface area. And in my experience, the pain always comes in development from crossing boundaries, from integrating between two separate objects, from deploying two separate objects and making and something that somebody said earlier, so that if we've had problems this week at labour rooms where there have been problems in live that were difficult to diagnose. And we were having to try and work out how several different components were interacting with each other and which one might be causing the problem. The symptoms were seen in several different, objects, components, whatever. With microservices, I can see how with unit testing you can say, okay, we're going to test this one service in isolation. But then when you start to integrate and you start to have acceptance tests that are going to be touching several different services that are not necessarily integrating or interacting in a straight line from top to bottom, they might be going kind of all over the place. And you're trying to say, I as an end user am expecting something. But if I don't get that something, whose fault is it? If all these different things, and that really worries me. And so what I want to know is at what point do you say it's worth that pain? What are the benefits that you get that make that pain worth it?
that again, bring an analogy by the way of the subject.
Yeah, I agree. It goes back to the problem we have in hand. And if we think carefully and look at the actual problem, most problems have a solution in it itself. You just need to find it. And if those services are not behaving as they should, or the expectation is not met, obviously one of them is on a fault, or maybe both of them on a fault. What is the compensation? Some operation has been performed and it's gone wrong. How is going to compensate for that, right? So the way I look at when eventually systems work, when I look at microservices, I look at eventual consistency. So the problem, I always give an example. When you go to ATM machine and you withdraw £20 and bank says, oh, I won't go any £20. Next, give you card back. When you look at your statement, they take the £20 out, then they deposit it back in. Check it next time. Anyone who's ever done it. So how their system withdraw the money, £20 to give it to you, but then they thought, hang on a second, the ATM does not have a £20. So the system itself compensates itself and says, you know what, I need to deposit that £20 back for it. So we need to be clever about these things when we jump onto microservices and say, yes, something gonna go wrong, and it's gonna go wrong, but when it goes wrong, how I'm gonna compensate?
Yeah, and then you've got compensation in each part. You don't get the problem further downstream. So if that is what comes back to what you said, if everyone's doing the job correctly, everyone's being fault tolerant, thinking about all these exceptional cases, you're not going to get these, or you're going to get much less problems further downstream.
Stay there, man. Stay, come back.
So just with the surface area analogy, because I think it's pretty good, is the surface area is increased with the cost. You mentioned two areas, which is where the increased cost comes in. We've been talking about the integration between many things. The surface area, I think, can be reduced if you work at improving the way that you deliver the software to cheapen it, to be more predictable, and the same patterns introduced over and over again. So,
Paul will know. If you ask the architect, especially a specific one, you probably know who I'm talking about, he would say, how do you check in the same? We need an API team. He would say, we need an API team who deals with the APIs.
You just need to repeat the same patterns and automation.
Repeat, you have to be so diligent, you have to be...
The other cost, which I've seen greatly on our teams, is the cost with the integration is that similarly doesn't understand when they do something over here, it causes a shitstorm over here. And
it only takes you make a mistake on how you're separating your microservices that you're exposing yourself to even more integration models and more issues on development that you wouldn't otherwise had you made it just slightly bigger or slightly more, or even not have created it at all.
Yeah, so the idea of that then is, I think, is to reduce the distance between the two points, and I think that's where communication between back context.
I think that should need to go.
Yeah, that's where the communication between your bounded context really plays into hand. So and. You saying about payback is, well, if there is no payback, then what's the work? What should you be doing? What do your systems do? Did you just lose a message and then 5 weeks later somebody realised something didn't happen? Or a lot of message queues now have dead letters, don't they? They have that on purpose so you can alert off them and go, oh shit, something's gone wrong. And that then reduces hopefully the distance between the source of the problem and the resulting
further down.
Issues.
So I think this conversation goes to the heart of what I struggle with, or perhaps the thing that's at the top of the list of things that I struggle with in this area. If we go back to that idea of a micro web service, is a bit of computational resource that lives on a URI, not URL, by the way. Yeah. It lives on a URI and it can do something for you. And what is the nature of the web? The web, and I know some of you work for places that have .com in the name, and I'm maybe going to find this a little bit upsetting, but the web is for things that don't matter very much.
I love making money out of it.
The web is for stuff where if you tried it and it didn't work, that's okay. The web is for things where the cost of failure is very low, and the cost of retries is very low, and eventual consistency could mean sometime next year, and that'll be okay. It boggles my mind that people are taking a technology which was invented to make it easier to share scientific papers. That is I can't remember exactly where it falls in the ISO 5-layer model, but it's towards the top. It's like an application protocol. It's the hypertext. What's the native language of the web? Is the hypertext transfer protocol. Hypertext transfer, not the bank account changing protocol. And banks have the protocols for doing that, and they're really hard and they're really complicated. These work with Swift. It's an unspeakable nightmare, and it has to be because it has to work. I've worked with people in, I think it was a pension, the fund manager attached to a pension company, and we were doing some stuff that talked to the Swift adapter and said, so what happens if you can't contact Swift? And the message doesn't go through, and they say, well, that's kind of the end of the world. So we don't really have to worry about that too much. The web is not for things like that. And this idea that you've got a technological concept that comes out of that world of browsing documents, non-critical, failure permissive, non-time critical sort of way. And yes, Ward gave us the magic of wikis and and showed that you could take post seriously, and you could take put seriously. Still, I think most web servers don't do an honest implementation of delete, because that's a little bit too frightening, right? That's a little bit scary that somebody could hit a URL and a resource is gone. No, we don't want that. The idea that we're taking that and building mission critical stuff out of it is terrifying. It's absolutely terrifying, and I'm sure that in these things go in cycles and fashions emerge and they decline, and I feel confident that sooner rather than later, and it might not be very long, we're going to look back at this whole building. It's great that you can use the web technologies to do stuff that isn't reading documents, and all the plumbing is there for you, and the load balancers are there for you, and the filtering and the types, and yada yada yada. That's all super wonderful. I'm sure we're going to look back at this idea, and microservices sort of takes it to its logical conclusion. You look back at this idea that you can take a technology devised for browsing non-critical documents now and again, and use it, sort of push it down the stack and treat it as the foundation for this pile of more and more important and mission critical stuff. We can look back at that and think, what did we think we were doing?
I completely agree with you. On that point, I really do. No, seriously. It's already starting. We got WebSockets. I got WebSockets that can send binary data between one point and the other and through the web. Why would I want to do that? Yeah, exactly. But we eventually get there. It's like it's a circular thing. We will get to a point that we're going to go and say, why the fuck are we doing all of this? Why can't I just go back to the AS400 days? Actually, that should work. The journaling system on that thing was amazing. It is amazing. It's still running. Many fucking business systems are still being run on it.
So the revolution's coming.
No, the revolution's already happening. Okay, it's just below the radar. Yeah. But no, I think the point is that we're microservices, and like I said, we did it before, and you guys mentioned it before. It's like the technology they do much better. It's already been doing since the 70s or much earlier than that. When somebody asks, and I used to be a cock in my previous job. When people come up to me and say you're a software developer, I say no, I'm not a software developer. I'm a software engineer. Because there's a difference. We have forgotten a lot of the engineering principles, and we're pissing the work of giants, that people before us who built things that worked. They went through this already. We are rediscovering with the wheel every day, especially with web frameworks and the HTTP and everything else. God, it's like I can connect. Why can't I just open a port and connect over TCP/IP, which is a great protocol, and it's got fault tolerance in it, to send you some data? Now you have to send me an HTTP request, which I have to acknowledge and send you back and say now you can upgrade, and then we can open that socket and transfer some data in probably JSON format, because I really don't trust ones and zeros. You know what I mean? Yeah. So it comes down to doing the right, knowing what you're doing. So if it's like you have really, it's quite right pointing out. It's like there are industries that look at what's going on with the HTML5 revolution, with what's going on with the microservices, and they're just laughing their head off. Just like, we did that like 20 years ago. And it pays their bills and their waters and moves 7 trillion pounds around the world every second. They will learn something. So they'll come back to us. I'm not saying that we're doing something wrong. I think, and I'm not saying that they. Well, we are. Well, it is. Yeah, I suppose it is. We are doing very wrong, but then again, we don't know well enough to know that we are doing it wrong.
Pissing away.
Just again, before we go too far away from microservices.
Sorry, because you said one thing on that about microservices, because again, there are things, things, as you said, there are things that have been built that do all this transactional stuff very, very well already. Yeah. And what we then have to do, if we're going to build it on top of microservices, basically means you need to know all that stuff. All that
you
stuff
do,
that's taken a lot of very clever people years and years to get into their heads, and decades. So individuals working in one area, you've then got to be capable of doing that. And this. And doing all this very well.
With those, though, you want to be making the choice of, do you need that? If you need that, then probably you might be using the technology. And it's all about the degree of what degree of control do you want. If you're going to do a TCP connection, then you're probably requiring a lot of control. If you don't require that great deal of control.
And it actually comes back to a lot of what Andy was saying, and I see a lot of people rushing to sorry, I will say the words every now and again, just so you know.
Microservices.
Microservices.
I'll count how many times you said, just to make sure it's in the right level.
I see people, for example, setting up Hadoop clusters to do all that stuff they do with Hadoop clusters, right? And it takes 15 minutes to spin up the cluster. And yes, the actual data munging goes like that, and then another 15 minutes to get it all out again. And that's preposterous. And the reason it's preposterous is that they're using big data tools and their data is not big. Most of our data is not big. If you're Facebook, your data is big. If you're Twitter, your data is big. If you're doing random stuff on the web.com, your data probably isn't that big.
4 terabytes is not big.
No, it's not. It's not. It absolutely isn't.
That's the size of our database, by the way. Most of these error logs. 2.2. It is.
That's compressed.
That's the thing. No, the point. We can make the database work much faster. We just did one table, so we'll be all right. Just say wanting to go fast, no problem.
And it's the same with you mentioned Netflix. If you're Netflix and you're piping HD movies with 5.1 Dolby to everybody in the world's house,
27 different formats,
whatever. It's so quite.
It's great, isn't it?
Then you've got a problem where this kind of level of architectural sophistication that comes from microservices might be worth doing. But if you're not, then you're not.
But even then, if a bunch of people don't get the fill that they wanted, they don't get whatever it is, Frozen 2 that evening, it may feel like a disaster.
Yes.
With small children.
It may.
But it's not a disaster compared to $1 million trades going AWOL, which is why people tend to not use these set of technologies to do the $1 million trades.
I'm not using this stuff. Yeah,
no, they won't. They'll be crazy.
Yeah,
Well, I'd like to say I completely agree. I mean, one of the arguments I heard, and I've been pushed at, was microservices help your database. Yeah, we've got 1,000 records on our database and it's running like a dog. If we split it into microservices, we can put one table there, and we get performance. And that is the truth. Yeah, that actually has been said to me. There's a company. I know. There's a company in Manchester, and a lot of people don't know about it. It's called Greater Manchester Police. My wife happens to work there, and they work on the Police National Database. This makes even Facebook look like a SQL Server instance on Azure. They have vast data going back 50 years. They run Oracle clusters that are monster machines, that take queries that take 24 hours to run. They don't need microservices. So do we, when we're storing an employee and an absence, do we need it?
No, not really. We just need to read something simple. It's just simplicity is key. That's all. So I want to rewrite into our microservices. I want to rewrite one of our applications, and I thought, why? It's like I think it was going to put into RPG. Yeah, something that was going to put in RPG, and I thought, why am I doing? I start doing it in Node.js to ensure in a microservice in Node.js. I'm sure there's an npm microservices. If there isn't, I'll coin down. I'll do it tonight. In Express, obviously. No, I don't like Express. I'm doing Connect because, I like to find things at my time. So I was doing it, and then I said, okay, well, I'll stop that. And I decided, instead, I'm just going to write the whole entire thing in one app. And I did it. It was about that big. It was using none, so you just done anything that big, not that difficult. And that was it. It was done. And I was like, that works really well. And it's for that specific problem domain was a monolith. It was a monolith. You hit the database at least 3 times to get data from disparate places and merge it all together and spat out the format that I wanted. And I say, that's it. My job's done. Why do I need then to? Then the other way around was like looking right from the top in Apigee or whoever we gave money to create API microservices APIs, and I would I have this format that I need to output, but I need to get data from 3 different places. So I would start looking and say, oh shit, I'm gonna have to call this service and this service and this service. Dump 80% of the data that comes out of this one, use about 1% of this one, and all of it. And when I get all the data together, I'm going to have to make a series of group bys and shit all the loops to just output some annoying XML format that I wanted. And it's like, okay, no. I would just build the monolith. I just build that one thing that does a job that I want. And that was it.
A colleague of mine's in his other job, stripping out, it's Steve, stripping out big data stuff from the publishing house where his other job is. Where they're looking at their data set is like the title and abstract of every article in every edition of this journal that's been published for the last 300 years. Type of stuff. It's getting into the realms of respectively large data. Yeah. And they were going at it with the big data tools, and probably also some microservices. And he's been taking that out and replacing it.
You're lost in that.
Replacing it with shell scripts.
Yeah. I can't imagine.
Straight up shell scripts. And maybe a little bit of the GNU parallel to push it out onto multiple machines if you really need that.
Yeah.
But of course, these days you can get a 4U box that's got 3 gigahertz cores in it and a bajillion megabytes of RAM and yeah. And you don't really need to, although you can if you want. And it's just scripty, pipey T, tail, get the thing out of the end. And that's rips through it.
I think going back to the point of microservices, and I think we just keep going on at it. It can be hard. I think it's hard when you're applying it to the wrong size of problem. It's probably very easy at a cost of whatever.
Maybe you would get misled by the word micro.
Yeah, it's
because actually you're absolutely right that it's the plugging it all together and the interfaces where all the complexity goes, and it doesn't disappear. It just gets pushed around and smeared about and becomes difficult to understand and difficult to manage.
Yeah, it does.
And the hard thing is just as hard as ever it was.
Yeah, it's still so if maybe harder. It will be harder.
Well, the essential complexity of the problem we're trying to solve is irreducible. Mm-hmm. And then there's a question of how much accidental complexity we're going to wedge in.
Very much.
And the trade-off is really strongly biased in
It is. It is.
If you've got a service that takes a customer and an army, if you was writing a monolith, it's a no-brainer. It's stored on the database. It's done. If you've got to write a microservice that deals with that, and you've got to write a service that watches the service to make sure that the service don't get out, and the service to monitor the service's service. Hang on a minute. How many services we've got to monitor each service? Are we sending a space shuttle up with a system that monitors a system that monitors a system?
If $1 trillion a second it's dependent on that service that watches the service, then you better put the service.
But if we're making
you wouldn't have that in the first place, but if you're in a situation, you would put as many as you could.
Although the actual space shuttle has 3, and only 2 of them have to agree.
I mean, but if our services making us 0.1 of a penny for every transaction, yeah, it's costing us about £10 to keep this service running and to develop this service. That's microservices.
You make that back on volume.
Good point. But it's going back to the point that it is great for the right problem and is for the right circumstances. Really, I think the key thing that I hope people will take out of this session today is that it's just you have to think really hard whether it's going to work for you, and we're contacted that for banking is no good, and we'll probably agree for banking you wouldn't want to use that, but everybody's got different problems. They have different domain problems. It's different, a different environment that microservices actually may be the answer. And
might not we know what the question is that microservices is the answer to?
No, it's not. We don't. That's the thing. I think that's what I'm trying to say. We will never know. We can. It's up to everybody. Everybody who is in control of deciding everybody's presented with a problem. They have to think really hard on the solution and make sure that if microservices is the answer, but be flipping sure it is the answer, because it's going to be expensive. It's going to increase. You have more surface areas to put, and you're going to have to pull. There will be more money going to operations to ensure the thing is running. Service desk you're going to have developers having to worry about message format and everything.
I just want to make a point that we've been talking about the increased cost in production of maintaining all these systems, but as I'm looking also, there's the cost of even getting it up and running in development. In the old days, you build a monolithic app, a new developer would join the team and they would have one app, say in C#, build it, run it, there you go. It's one system. We're in the position now, the team I've joined, that we've got a service which has, we have 6 microservices for this one product. 5 of them in .NET and 1 of them is in Node.
Yeah.
They also rely on an event stream and an NoSQL database. And now actually getting all of this up and running when half the team are on PCs and half are on Macs.
Don't forget that nobody know how to use the NoSQL database and the event, because Rabbit's so mainstream, and we're hipsters. We want the Apache project.
We're bigger than Rabbit.
We're bigger than Rabbit. We are bigger than Rabbit. We need the stuff that big boys play with, right? It's like, nah.
So yes, now we've got this position that it's ridiculous even trying to get the thing set up and running on a new machine. It's difficult to get it working at all.
I can echo that. Dev the other day, he did a change. He did a little microservice, and he said, "I just need to test this." And he said, "Well, I need to install this one." And he ended up with 6 microservices running on his laptop. And going, still don't work because I didn't start that one because that one, and there was an end service issue, and service bus issue, and then it was
We've also got the problem with the integration tests on this one now, because yes, we have the end-to-end test because we're all good and have end-to-end tests, but we've got people working on the different microservices, and they make a change to behavior over here. Excellent, change the test, pass. Someone working on a completely different piece of behavior on a different service on a different machine suddenly gets the latest version of the test, and boom.
Yeah, we had one where we've got the domain, and the domain objects, they changed. Yeah, some services had this version, some services didn't have that version. They were picking up, that was picking it up, why not? Nobody knew. So we actually went through and looked at every version. There was actually there's some one out. So we had to recompile it to redeploy it.
May I add that
was local.
One of the things that I've seen recurring, constantly popping up in this discussion this evening is the whole, you should only use microservices when you're this complex and when you're this tall. And what I've been thinking about a lot is how much I believe I now fully understand the true impact of the use of microservices and the decisions that you have to take when choosing that. And this may be a little off topic, so someone replace me quickly.
No, just say microservices.
Microservices.
On topic.
But one thing that's come home is the principles of XP, the principles of what we should be advising people as software professionals, and emergent design, and how, like, don't jump to big data just because it's the new cool. Don't jump to Redis cache when you could just hot serve it from the database until you need to optimize. You know, don't optimize early. You know, do these things later so it's emergent design. Don't go and microservice the bad boy up until you're this complex and you're this high. And I feel that I wanted to add that I feel everybody that's been part of this discussion, that's been involved tonight, that we're all duty bound to be pragmatic and to educate those that we influence about the truth of the cost of microservices and such things. At the end of the day, we are the professionals, we're the ones offering the advice, and I was kind of blown away by just how much you're really saying when you say to somebody you should use microservices. You know, that comes with a big fat price tag, and I don't know what the conversion rate is. So I just wanted to kind of put that out there, that I think it's a mindfulness, that it's a tool in our bag of tools, and it has its uses, but if you're not this high, you're going to break the system.
It's a responsibility. We should have a responsibility to a customer or a company you work for, to advise.
Well, you're a cowboy. Not you, but just
yeah.
One is a cowboy.
So is it a case? I've not read enough into Netflix, and I probably should have done. But did they go? They are obviously the poster child for microservices. Did they start microservices because their customer base got too big to be able to run in monolithic apps? Did they have to find some way of partitioning it up?
I think that's basically what it is. I went to a talk on it a while ago. That's basically what they said. We had this application that worked really well, then it just got too big, couldn't go, performance wasn't good enough, so they thought, how can we do this? So they split it up into microservices simply so that they could scale. Because you can have one microservice serving things, but then as you scale, you can have 2, 3, 4 of the same thing, doing the same job and scaling it out. And that was their big driver for it.
So a couple of points that both of you made was about the cost of you trying to run your app and you've got to talk to like 5 microservices. I think you kind of have that same problem anyway in other instances, like when you're using service oriented architecture or distributed architecture. Similar with bounded context, you know, they're not microservices; they can be quite big services, and you still have those integration points. But regardless if you're using microservices or larger services, you're still going to always have those problems, and you have to protect your application to a point where you can actually run it regardless of those services. So that's where your ports and adapters and your trying to create an imperative shell around your application to avoid those issues, so you can run it in isolation. At that point, you do end up needing to ensure you've got a real good test environment and the right level of integration tests and your end-to-end tests as well. But without those, you will always have those problems, even if you're talking to a monolithic service.
That's just good engineering practice.
Yeah.
But then it boils down to experience again in the team.
Yeah.
If you've got an experienced team, you're going to have an excellent model. You're going to have an excellent microservices.
Have you got your pyramid of tests right? Doesn't always happen.
No. How many times have you heard, what's the test? Yeah.
So one of the things that came up a lot in the survey recently was testing. So I wonder if perhaps we could delve into that. What are the right level of end-to-end tests, integration tests, unit tests for microservices, and does that differ from monoliths?
I think on paper, microservices are very enticing because it looks like you can test each one in isolation and not give a damn about what's happening in the outside world with the other bits, which is a bit disingenuous.
Yeah, because nothing ever glues up the
Because when things blow up, it's always, when you put them all together, they all look fine individually.
I think one of the things I keep reminding myself every morning, a very basic software engineering principle. Keep it dry, shy, and tell the other guy. And when we look at the system, most code bases I've seen, they all violate that. So all I'm going to say is be pragmatic, look at the actual problem, and think about carefully what we actually trying to solve. And again, I'm going to repeat that: keep it dry, shy, and tell the other guy.
If it's somehow testing in microservices, the problem I have with the testing in microservices is one of the things we lose, or one of the bits of complexity we gain is configuration management. So we create potentially, with a lot of services, a configuration management nightmare for ourselves, in the sense of what is our application? Well, it's that set of services. Well, which set of services? Which versions of which services? With which data? So I used to suffer from a bit. So what I'm trying to project this onto a bit of my previous experience, which is a large bank where we had test environments and we had applications or bits of the applications like mainframes or this sort of thing from different teams. So this is in many ways it's like a microservices thing. There are various bits of the mainframe that various different teams on the mainframe maintained, and the test environments would all have different versions of those mainframe subsystems that wouldn't match with what was in production, because they were also testing in the test environment. And therefore, actually trying to get hold of something that looked anything like live with a combination of different services that are all served by different teams was a complete nightmare. And a lot of it, you then have to take a risk-based approach and say, well, they're changing this area, so probably not going to change us that much. Therefore, we'll cross our fingers, we'll roll it out at the weekend, and then if it fails, we'll have to roll it back again, and we'll need another 3 months before we can try again.
Something we've had to do. We had it set up originally so there was a CI environment, and yes, each time a service, anyone committed to any of the different services, it would build them all, it would deploy them all, and it would run all the tests against them. Which did actually work to a degree, yes, the developer.
Loop a bit slow. Feedback loop a bit slow.
But the real problems then came that this meant that it was a bit of a shifting mess for testing, for the actual manual testing, the QA, deciding what actually got released. And we had to introduce a second layer of UAT, where that's fine that there's the CI stuff, but for actually doing a live release, the QA has to pull in manually which service, and just one service at a time they want to test, and then preferably just release. So only one service changes at a time.
But aren't they essentially then just having a soft monolith in the sense of this is the set of configuration that we're happy with, and that's therefore what's going to go out?
So one thing you have to consider is about with microservices, does it, because you're talking about those issues with having different versions. And I think with microservice services, you want to be releasing them as quickly as possible. So if you have a long process between doing a change, confirming it works, and releasing it, if it's too long, you increase the likelihood that it's going to be wrong before you release it because of different versions of other microservices. So with that point really, it's about one of the prerequisites I think you need to do with microservices is the ability to release quickly, because in that window, nothing else should have changed, and you confirm that everything that is in that test environment is probably live already, given that you're the only person who made the change 10 minutes later, you've already released. The problem is it doesn't really work like that in real life, and it often takes far too long. But then it needs to, I guess, fit in with the culture of the business. Does the business require you to release that quickly as well?
But the thing is, if you've got a set of teams, I mean, the one thing that I think that vaguely strikes me as being at all sensible around this is the idea of having people aligned to particular, partitioning the team. So you're reducing the complexity area, that if somebody's new onto the team, this sort of thing, you reduce the amount of things they've got to deal with, rather than there's a whole monolith of stuff and you've just got to deal with any of it. So, if you've got a whole set of different teams working, if they're all trying to work that fast and say, we need to keep deploying very rapidly, very regularly, there's no, potentially you could have thousands of changes to the live system every day, because if you've got 10 teams all pushing 100 changes in, they're trying to be really fast, and it seems to become impossible to actually pre-test that. That there's no way your tests can run fast enough to keep up with the fact that we just about got to the end of the test and bang, somebody else has put something in. Oh right, okay, let's go back to the start of the test again. And
that was part of the reason also having the QA manually pull the changes through onto the test. Was when they was just triggered automatically, yes, they'd be halfway through the testing and then something else would trigger it again.
Yeah, that's
bugger, who was that? Who's that?
The right sensible approach for your business, your department, your size of company. your need to be able to, how often to deliver it.
Oh, indeed, but this is where it gets into the question of what, Steve was saying, what these technologies are meant for. So I remember having this thing a few years ago that I saw Fred George from Forward, I think, what we call developer anarchy, where they were just committing all the time directly. And then Unruly Media seem to do this as well. If you look at Rachel Davis's teams and their presentations, they seem to commit directly from the developers' machines, which for most organisations, like a large bank, they would, the risk people would just shut it down. There's no way on earth they would ever allow you to do that. So the question with some of these is do they actually, you're right, do they actually fit your business? Because if you are looking to do that sort of deployment, the only way you can manage that is to monitor it in production and then roll back. But obviously, if you're doing that, then there's a question of compensation. Can you actually compensate? Can you actually work out what the hell went wrong? And if there's persistent data and transactional data, unraveling all that could be
and then you've got the tooling to be able to roll back quickly.
Correct. So you just can't work that way if you've got that sort of transactional data.
Yeah.
I think one of the basic concept is when microservices have a contracts, they have to be well-defined contracts, and they should hide the complexity behind those contracts, and only expose a well-defined interface to whoever the consumer is. And the way I look at the testing microservices, I can repeatedly say, here's my input, give me the output. Because something is going in, something coming out. It's doing something. And I can say to microservice that here's my input and what's my output. And I can, well, in our CI environment, we can set up the system to say, okay, fire up so many requests and get the response back and see if the response back is one of those things which we expect.
But the problem is it's not with the individual service, is it? It's the network effect. It's the fact that if you're saying we want to create a set of services because we've got a complex monolith, we'll make it simpler by cutting into services so we can understand the services. The complexity is still there in the overall deployed system, and therefore, if we couldn't understand the monolith because it was too big and complex, we can't really, in the same way, we can't understand the deployed network system because it's too complex. So therefore, even though that bit, we can run the tests against it and it comes back fine, unless we actually understand exactly how all the different potential paths through the system work together, there's no way we can predict what the consequences of the changes made on that will have on anything else.
What about use of microservices in a very distinct way? Like if you think about something like Spotify, where you've got this kind of host application, and then each part of that screen is a different team working behind it. And actually, there's a real separation between the top left and the top and the bottom right. In terms of the team is going through the whole stack. They're doing the front end, they're doing the microservice at the back, and they're doing the database. Then they can test that feature from the previous version. And you see what I'm saying? You're using microservice in a way that doesn't talk to another microservice in that sense. But then again, you're distributing out the system. It's discrete. It's decoupled from the rest.
But I think there is I can't remember the reference to it, but I'm sure I read something about Spotify that was the intention of what it did. But then what they found was that a particular service, a particular thing. We're now introducing this over here, and
that needs to change further up.
The users expect the two things to work together. Yeah. And not that, that bit down there in the bottom right doesn't know diddly squat about this new whizzy thing we just introduced in the top left. It'll come at some point downstream. That got very bad feedback from users. Therefore, they found that they did that coupling. The coupling came back again because they had to make sure the different bits of the system worked as a coherent whole for the customers who are feeding to.
Right, and then you're back to this conversation. I'm just an idea.
Good idea.
Well, some of the things we can use is these small tests. I think one of the things I've used in the past is every single time when we deploy a complex system, run some basic small test on it and see if the system is behaving correctly. And I admit there was some manual testing involved after those smoke tests, because some of the things could go wrong when the smoke test wasn't capturing those things.
But it's all about risk, isn't it?
Yeah,
it's
it
all,
is.
you know, testing is all about risk. So,
Exactly.
Which is why, for people like Unruly Media, for example, it's a lot less risky than pushing to production, because their context is they are governing which videos people see. When they hit a particular site and you get a little video, those 9 video clips that you've got to watch for a certain amount of time and that sort of thing, they're ensuring that the right type of people see the right video clips and that they're paid by advertisers to make sure that happens. So if their system goes to shit, what will happen is people see the wrong videos. You know, nobody dies, nobody loses money. They just get some rather annoyed customers when there is brought it back to them the fact that their new video for the Volkswagen Golf hasn't been shown to 3,000 users of potentially people who are looking to buy a small new car.
I think there's one thing about the confidence level from the client or the customer drops on the team, and then they start adding constraints that Friday, Saturday, Sunday is our busy day, so don't you dare touch our production system. So that is a very important thing, because when releases go wrong, the confidence level in the team and on the client side as well, they go down. And only one bad release can destroy all of the hard work that the team has put in place to get to that level. And then you start all over again and trying to say, don't worry, we will release. So it's very frustrating for a developer.
But that's true regardless of whether you're deploying a monolith or deploying a set of microservices.
Yeah, so it goes back to, it's a risky, we're not killing someone. We're not writing software for, at least I'm not writing a software for a live sport machine, which we were discussing earlier. If I'm writing a software for a live sports machine, I would probably be sweating a bit more.
But equally, you wouldn't be using, again, coming down to Keith's point, you wouldn't be using these technologies. You wouldn't be using microservices and HTTP and this sort of thing for live sport machine.
Yeah, so...
Sorry, 404, not 4.
Is that machine there or a customer?
Yeah.
But what we found is, like, the one thing we found was we use a consumer testing, so what it would be is like another API or like front end or whatever with consumer API. It would set up what it expects to get back, so the test would run and it would go, right, I'm going to send this request, and it would send the response, it would match up, and that's how you would get that redundancy between the two systems. So rather than having just one area going, all right, I'll just test this one stat, there was that communication testing. It's like, because of microservices, there has to be that further test, so it's not just the general spec flow unit test, you have to do that extra level of making sure the communication is tested properly, so you are getting the right responses back, so you've got that feeling. So if you do change a contract, you need to make sure that the other places are aware of it.
But it's a question of how much testing you do. You know, you've got combinatorial explosion of a number of services, and the different paths through those services.
A good measure, I think, is to always ask yourself the question, if you think you've got too many tests at a particular level, is to ask yourself how many times you see them fail. If they never fail, then they're probably not actually much use. So an example would be, we had nearly 200 integration tests that actually went off and used the website and proved that it all worked. In fact, we probably just needed 9, because whenever one failed, it was actually like a quarter of them would fail at a time, because you fundamentally broke something. You delete all of them and just have the 9 tests. What we end up with actually is a really fast feedback loop, and we know we've broken something really quickly.
Which is a good point, but it's completely orthogonal to microservices.
It is.
One of the things we discussed now,
but it may help if the explosion of integration tests occur because of the communications between your applications and microservices, etc. And you're trying to prove all those things. A lot of the time, a happy case test, a single happy case test, will prove that you've got your connections between.
Yeah, but one of the things.
Just before we move on to anything else, I think maybe we should carry this on in the pub. I'm very aware that it's very hot here, and lots of people have visited some uncomfortable chairs for quite a while. So, I guess, in conclusion, microservices are pretty hot.